This video is about ratios and proportions. And so we're going to look at how to write ratios as fractions, how to solve proportions, and then we're going to look at solving some problems where we model with proportions. So the first thing we're going to start with is writing ratios as fractions. And so we need to make sure that we understand that a ratio is just a quotient of two quantities. And we can write that in a few different ways. And so we can write a ratio in this form where we say 1 to 2, or we can write it as an actual fraction, 1 over 2, or we can write it with a colon, 1 to 2. If we wanted to write it as a fraction, the order of the quantities is important. It makes a difference which one is first. So to write a ratio as a fraction, we always want to make sure that the first number of the ratio is written as the numerator, and then the second number is going to always be your denominator. Remember, the numerator is on the top and the denominator is on the bottom. So in your ratio, the ratio of a number A to a number B is going to be the quotient, and it's always going to be written, like I said, that first number is going to be your numerator. The second number is going to be your denominator. So let's look at some examples. If we wanted to write the ratio of $25 to $15 as a fraction in simplest form. So our first number is going to be our numerator. So we've got $25. The 2 tells us we've got that ratio. So we're going to have our fraction because it says we want to write it as a fraction. 15 is going to be our denominator because that's our second number. The dollar signs are going to cancel out. And so now we just have 25 and 15, and we can simplify that. So if we break that down into factors like we did when we were simplifying fractions, we could write 25 as 5 times 5. We could write 15 as 3 times 5. And so they have this common factor of 5 that can cancel out, and that simplifies to 5/3. And this is just simplifying the fraction. And so that ratio would be 5 to 3. Example 2. We want to write the ratio in fractional notation in lowest terms. Remember, lowest terms just means simplify. So again, we've got 15 miles. 2 tells me I've got that ratio, 50 miles. Again, those miles are going to cancel. And so I've just got 15 to 50. I'm going to try to rewrite that so I can simplify it. So I could write 15 as 5 times 3. And 50, I could write it as 5 times 10 because I'm trying to find that common factor, which in this case is 5, and that would cancel. And so I've got 3 to 10. And I'm just simplifying that fraction. Example 3, we've got an applied problem here. So it says write the ratio of the shortest side to the perimeter of the right triangle. So we want to make sure when we write this ratio that we're doing the shortest side. So we want the short side to the perimeter. So remember, order matters. So when we set it up, we want to make sure we have the short side over the perimeter. So if I look at the sides of my triangle, the short side, about 45, 51, and 24, would be 24. So that tells me, okay, I'm going to have 24 meters as my numerator. Perimeter, remember, perimeter is the length around a figure. So I need to kind of come do some side work here and find the perimeter. Perimeter, I'm going to add up all those sides. So I'm going to add 45, 51, and 24. And that gives me a perimeter of 120 meters. So I'm going to put that as my denominator. 120 meters. And now I have my ratio. All I need to do is simplify. Again, those meters are going to cancel, and that leaves me with 24 and 120, and so that common factor there would be 24. So I would just write that as 24 times 1, and 120 can be written as 24 times 5. And so I'm taking that 24 out of each, and that would just leave me with 1/5. So that ratio would be 1 to 5. Okay, let's look at another one like that. So here I've got a rectangle, and in part A, we want to find the ratio of its width to its length. So width to length. And sometimes it's helpful to write this out in words first to just kind of make sure you're looking at the different pieces and make sure you're setting it up correctly. Okay, so I'm going to label this. So this is length. This is width. Okay, so my width would be 5 feet. My length would be 7 feet. And then, again, my units are going to cancel. And I can't simplify 5 over 7, so I would just have 5 to 7. Okay. Part B says find the ratio of its length to its perimeter. So, I'm going to start by writing it in words just to help me organize my thoughts. And I know the length. The length is 7 feet. But I do need to do some work to get the perimeter. And so perimeter is all the length around the outside of the figure. So I know this side here is going to be 5, and I know this side here is going to be 7. Add in my units. So the perimeter would be all the way around. So I'm going to say P equals 7 and 5 and 7 and 5. And so that's going to give me a total of 24 feet. And so I can put that in my denominator. Again, my units will cancel. And so that leaves me with, again, I can't simplify 7 and 24. Nothing divides into both of those. So I just have 7 to 24. Okay, our next topic is writing a proportion. So a proportion is just a statement that two ratios or rates are going to be equal to each other. So for example, if I have 5 to 6 equals 10 to 12, that's a proportion. Okay, and when you're reading that, it's just going to be 5 to 6 as 10 to 12. And so for solving this, we can use this to find some missing pieces. So if we wanted to solve a proportion, that means we're going to find that value of whatever that unknown piece is. In this case, that piece is x, that missing piece is x. And so what we're going to do is what's called cross multiplication. So our operation is multiplication, okay? And so we are going to basically cross multiply, okay? So that means we're going to set our cross products equal to each other, okay? What I mean by that is I am literally going to cross multiply. So I'm going to multiply the 4 times 22, okay? So that gives me 88. Then I'm going to multiply 11 times x. That gives me 11x. I'm going to set those two cross products equal to each other and solve that equation. So if I do that, I get divide both sides by 11. I get x equals 8. Same thing on the next one. So again, I'm going to cross multiply 5 times 3, so I get 15. I'm going to cross multiply. 9 times x, I get 9x. Those cross products need to be equal. Divide both sides by 9. And so x equals 15 over 9, which can be simplified. And that would become 5/3. Right? So let's look at a couple that are a little bit more involved. So here, same thing. I have two ratios equal to each other. And I know they're two ratios because I have one fraction equal to one fraction. And since that's what I have, I can cross multiply. So I'm going to multiply this cross product. And when I do that, I'm going to multiply 6 by this entire numerator. So that means 6 times all that. That's going to equal 5 times all that. That means we have to do some distributing because you've got to make sure that each piece gets multiplied. So 6 is going to get distributed through here. So 6x plus 6 equals 10x plus 20. And now I can solve this equation. So I'm going to subtract my 10x over. So I've got negative 4x. I'm going to subtract my 6 over. That goes away. That goes away. And I've got 14. I can divide by negative 4. And so x equals 14 over negative 4, which is going to simplify to negative 7 over 2. Okay, same thing on this one. We're going to cross multiply. So 3 times x equals, here I've got 9 times, but I've got more than one thing here. So I've got to make sure I distribute that. So 3x equals, I'm going to distribute that 9 through. So 27x minus 72. Now I can solve. So I'm going to subtract 27x. So I've got negative 24x equals negative 72. Can divide both sides by negative 24. And so x equals 3. Let's look at a couple of word problems. So example 6 says a can of lemonade comes with a measuring scoop, and directions for mixing are 2 scoops of mix for every 34 cups of water. How much water is needed to make the entire can of lemonade if there are 40 scoops of mix? So the first thing we need to do is pick out our ratio. So it says the directions for mixing are 2 scoops of mix for every 34 cups of water. So if we think about our ratio and we wanted to think of it as scoops of mix to water, okay, well, how much mix do we have to how much water? So it says 2 scoops for every 34 cups. So there's my ratio. And then it says how much water is needed. Okay, so I don't know about the water, but how much water is needed to make an entire can of lemonade if there are 40 scoops of mix? So if I then go in and I say, okay, well, I don't know about the water, but I do know that I've got 40 scoops. Well, anytime we have an unknown, we're going to use X. Water's cups. And there's my ratio, there's my proportion. Because proportionally, I want it to be the same as what the measuring says. So here's my proportion. Now I just need to solve it. So I'm going to cross multiply. 2x equals 34 times 40. So 1360. I'm going to divide by 2. So x equals 680. So what that means is I'm going to need 680 cups of water. Okay. Example 7. A punch recipe calls for mixing 6 parts of cranberry juice with 5 parts of strawberry juice. Find how much cranberry juice should be mixed with 90 ounces of strawberry juice. So again, let's find our proportion. Let's find our ratio. So 6 parts of cranberry juice gets mixed with 5 parts of strawberry juice. So we're comparing cranberry to strawberry. Okay. So it says 6 cranberry to 5 strawberry. All right, then it says find how much cranberry juice should be mixed with 90 ounces of strawberry juice. Okay, so I want to make this proportional. So how much cranberry juice? That means I don't know about the cranberry. So X cranberry. 90 ounces of strawberry. So 90 is my strawberry. Now that it's set up, I'm just going to solve. So 6 times 90, 540. 5 times X. I'm going to divide by 5. And so X equals 108. Now, units, this is talking about ounces because it said 90 ounces of strawberry juice. So 108 ounces. And it wanted to know about cranberry, so 108 ounces of cranberry juice.